Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Cruise to Cloud Native Chapter 3, bringing your team on board into your cloud native journey, brought to you by Datadog and AWS. Before we get started, I do have a couple housekeeping items I need to go through with you. First of all, the session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will also be there for you. We're doing a drawing at the end for 4 $25 Amazon gift cards, so stick around to see if you are a winner. And we are taking questions throughout the webinar, so don't wait, don't hesitate. Get your questions in for our awesome panelists today, and we'll try to get to as many as possible at the end of the webinar. All right, well, with that, I am pleased to introduce to you today Ara Pulido, who is a developer in developer relations with Datadog, Daniel Marr, developer relations at Datadog, and Stuti Deshpande, who's a solutions architect with AWS. I'm gonna turn off my mic and my camera and hand it over to Ara to get started. Thank you so much.
Great, thank you. So as Sharon said, my name is Ara Pulido. I'm a technical evangelist at Datadog, which basically means that I love playing with technology and explaining it to others. That's my Twitter handler. If you want to reach out, ask questions at the end or afterwards. And I'm here today with Stuti and Dan. Stuti, do you want to introduce yourself?
Sure. Hi, everyone. I'm Stuti Deshpande. I'm a partner solutions architect at AWS. I work with our wonderful partners in the AWS APN network. And today I'm here to just have a really good conversation with all of you.
And Dan?
My name's Dan. I'm on the community team here at Datadog. Alongside Ara, we do more or less the same thing. She just does it a little better than I do.
That's not true. Okay, so this is episode 3 on your cruise to cloud native. And I don't know if you watched the previous episode. We had episode 1 in the 7th of May, episode 2 the 16th of May. If you didn't and want to go back, those are recorded, so you can watch them. But basically, to give a little bit of a recap, this is what we were trying to accomplish is to mimic the cruise to cloud native that a company may have when they're moving from traditional bare metal, traditional infrastructure to the cloud, to the public cloud, in particular AWS in this case. So in episode 1, we did the first thing that people do, just to do a POC and trying to see how to move it to the cloud and what are the metrics, what are the things that we need to look at when thinking whether that POC has been successful or not. On the episode 2, we did a little bit more because on episode 1, we just used like something called lift and shift and lift and reshape, which basically is the same things that we are doing on bare metal, just move them directly to the cloud on virtual machines, on EC2 instances. But on episode 2, we saw a little bit more. We started identifying services in our application that may live in better compute than just EC2. And we saw things like AWS ECS Fargate and Lambda. And we also saw that as soon as you start splitting your application into components, things like profiling and distributed tracing can help you find issues that may happen on your application. On this episode, we are shifting gears a little bit and we're moving just a little bit away, not too much, but just a little bit away from the technology itself into a little bit of culture. So now you've done your POC, you're loving moving those services to the cloud, how you can get the rest of your company on board. So that's what we are going to be diving in today. And I'll pass it on to Stuti so she can start.
Thank you, Ara. So as Ara mentioned, today we are kind of, diving deep into what are the challenges that basically our customers are facing at AWS when they're trying to move to the cloud and trying to adopt the DevOps culture, really. So some of the challenges that we see is basically, moving the existing software contracts, having the license that can be portable in AWS platform. Some of the customers also want to kind of include software vendors, which are completely new to their platform during the migration. And some of the customers also want to kind of bring in the on-premises governance and control into the cloud applications that they'll be deploying on AWS. And sometimes it's really about the culture in the organization, about the skill set, about the mentality of whether we are moving from monolithic to microservices architecture. So those kind of challenges we have been hearing from our customers. And if you really want to kind of categorize all of these different challenges that we hear, there are these three categories that we have seen: culture, practices, tools. Culture is basically constituted by the people within an organization, and really the skill set and adaptation to change could really be certain limitations in moving into a cloud native architecture. Practices could include, related to moving from monolithic to microservices architecture, deploying the code in rather than having a single pipeline of CI/CD, really moving into the continuous integration and continuous delivery, which we call as CI/CD pipelines, and deploying the entire infrastructure as a code. So those are certain practices that are new and that they are evolving, and that could be pose as a limitation or could be a challenge. And sometimes the tools and the services that our customers are using, they probably would not well integrate with the cloud platform, and it fairly seems kind of really impossible to include all those different tools and services that they have been using on premises, and how they can leverage that in the cloud. And again, it goes back to the culture, where it really is about the skill set and the mentality of adaptation to change. So if you really think about, consider an example, right? How you will integrate applications and modular services into AWS. So just taking as an example where you are trying to build and trying to make a decision on whether you want to do a synchronous based application or an asynchronous. So basically, you're talking about API based versus event driven. So there are certain factors that you would want to consider before you actually make a decision. So those are the indicators that we call as, and those are scalability, cost, latency, and agility. These are the very determining factors whenever you are taking some data-driven business decisions. So say suppose you're building an architecture and you are thinking about, okay, what do I do? Whether I go with the API-based or event-driven, you consider moving towards event-driven, because in event-driven, you are basically getting a huge cost benefit. You're also getting the scalability and elasticity that you're looking for. You're actually, the entire architecture is kind of divided into microservices-based architecture rather being dependent on the monolithic architecture. So you're actually kind of dividing the architecture into microservices. Your architecture is scalable. It's elastic. It can scale from 0 to nearly infinitely scalable kind of services. So those are the certain indicators that are really important when you're considering in taking some decisions. And considering these factors, what we have seen across the board, what our customers have realized is 88% return on investment. They have seen a significant improvement in the latency, significant reduction in the cost of investment they are doing, and they are getting huge benefits in terms of scalability, latency, and agility. I would like to quote one of our customer examples, which is Verbo. They have seen 12 times increase in the innovation pipelines when they tried to move into the microservices architecture and you start utilizing AWS services. And similar story can also be seen for an overall Expedia group. I know Verbo is a subsidiary for Expedia, but for an example for an overall Expedia group, what we have seen is like in 5 times increase in the same innovation pipeline that they have invested since 2016 due to moving into the microservices-based architecture and starting to utilize AWS services. So what we are really talking about is the organizations, the challenges that they have been facing, but if they really see some of the factors and the indicators that really tells them that moving to cloud would have a significant impact and significant return on investment. So now the customers are realizing that ROI and moving fast to the cloud. But the main challenge comes how they can have the same governance and control which they were having on premises into the AWS cloud or in the cloud native application. So with AWS, what you can do is you can move faster to cloud and also stay secure. And let's see how you can do that. So basically, what we have in AWS is a layered security services. We have we have defined security services in various different layers, which we call as identify, protect, detect, respond, and recover. So in identify and detect, what we have is you can have those security services which are in the AWS platform that will really perform the logging and monitoring. We can identify the security threats and you detect them and have them in an automated fashion so that it doesn't occur in the future. In the protect and respond, what we have is you can have an automated response plan. Whenever a security threat happens, you are actually seeing a pattern and then you're responding in an automated way. Just to protect your infrastructure and save your architecture components from further security threats. And in recovery, we have automated tools and services which will really help you to regain your infrastructure and remediate all of the security threats that have been encountered in your infrastructure. So we have different services in these different categories, which we call as a layered security services at AWS. And really, if you think about it as an overall overarching concept, it's actually AAA. So what we call as authenticate, authorize, and audit, which is AAA with AWS. In authenticate, we have IAM, which is our identity and access management service, which you can utilize to bring all of your organization users and groups into the cloud, which you can utilize as IAM. And we're going to a little bit talk about how you can do it. But just consider IAM is identity and access management, with which you can authenticate your users and groups. With authorize, what we have is IAM policies. So there are different users which need certain access to perform some certain activity. So utilizing IAM policies, you can authorize your users and group to perform certain actions on AWS services and your solution components. And with audit, CloudTrail is one of the services that you can use where you can log access to all of the different services and components within AWS platform, just to have a secure place where all the audit logs are stored and those all the access logs are stored, and then you can utilize those logs for auditing purposes in future. So what you get in security portfolio with AWS is AAA. So as I was mentioning, the identity and access management, basically there are some principles that you can create. And by principles, I mean there are certain, there's a root account. So whenever you log in or create an account for the first time with AWS, what you have is the root account. We recommend that you should not be using root account because of the fact that root account is a super user. It has access to all of the different services, everything. It's a console, it's API, all the services. So root account is like a master user that you should not be using. What you can do is create different users and groups. For example, your organization have different teams, right? You have developer team, you have a testing team, and data analyst. So you can create different groups within IAM and assign relevant users to these groups and assign policies. So developers, whatever access developers needs, they should have appropriate access, what we call as the least, having the least privileged access. So all the users should have only that much access that needs to be there in performing their task. So you can assign those kind of roles. So using IAM roles, you can assign these permissions and policies to your users and group. And then we have temporary security credentials. So, if you want to have access to certain specific services, or if you want to have access to console or APIs, and you want to provide that to any third person or a third party vendors, you can utilize those temporary security credentials, which will be valid for a certain duration of time. And then you can prepare, define the life cycle of those temporary security credentials. So now there are, certain best practices whenever an organization is planning to move their security and governance and control into the cloud native applications. And when they're, moving into our AWS platform, there are certain best practices that we have observed. And one of them is, clearly defining an account creation process. So basically understanding who in an organization is creating AWS accounts and what they will be used for is really crucial and essential part of the account planning and the security strategy. Many companies are creating a centralized process for creating AWS accounts. However, centralization, is not actually required as long as the process is well defined and allows an organization to maintain the account inventory. So centralization is not that much required. Then what we have seen is defining a company-wide AWS usage policy. So implementing a well-defined AWS usage policy and vet them with company stakeholders to align with the business and security requirements is very crucial. What is a usage policy? It's basically a policy that should include an organization's minimal security baseline requirements for the different ways they will be using AWS, such as which services are approved for what, or what security or encryption features should be enabled. So those kind of baseline requirements needs to be set with the AWS usage policy whenever you are trying to define a company-wide AWS accounts and the policies. Then the third one is creating a security account structure for managing multiple accounts. Creating a security relationship between accounts really makes it easier for an organization to assess the security of AWS-based deployments. And you can centralize the security monitoring and management. You can manage identity and access across different services and components, and provide auditing and compliance kind of services with these monitoring services that you're having. And lastly, leveraging AWS APIs and scripts. So many organizations today leverage AWS APIs and custom developed scripts to automatically and consistently apply these baseline configurations, which are security thresholds and everything, across the multiple AWS accounts. You can consider, leveraging compliance monitoring scripts to provide insight into how well an organization's accounts comply with this defined set of policies and standards for AWS usage. So these are, a couple of best practices that we recommend, and that what we have also seen when an organization is planning to move to AWS-based management for their identities. And lastly, when they move into IAM, what are the general best practices that we recommend as part of IAM service? So basically, you should not be using the root account. You should be creating IAM users. You should be creating groups, and only relevant users should be assigned to those groups. We follow the least privilege policy, so the user should have appropriate access and not more than that. And then we definitely recommend having multiple layers of authentication, so enabling MFA, configuring very strong password policies, rotation of whatever access keys if you're assigning to your users regularly, and that life cycle can be dependent on your business requirement, but that needs to be done as a security measure. If you are sharing credentials, that is not recommended at all. If you are inviting any third party to have access to your AWS services, then temporary credentials should be created for their usage. And then whenever a user leaves the organization or changes the role within the organization, you should be just revoking the access and manage life cycle like that. And I think the another part is, like monitoring AWS account activity whenever your users are, changing any roles. So you can leverage monitoring services that we have along with the IAM. With that, I will hand over to Daniel.
Thank you so much for that, Studi. So hard act to follow. I'll try my best. So Studi, you talked a lot about best practices, right? Which is good and true and correct. And I love best practices. I talk a lot about best practices too. So I'm going to talk some more about best practices. You also talked a lot about security, which is another subject that's near and dear to my heart. So we're going to talk a little bit about that later on as well, especially in terms of like monitoring and security posture and whatnot. But before we get to that, I'd like to introduce some acronyms. And again, it's, some more of these best practices. And it's these acronyms that you can see on your screen right now. Technical people love acronyms. In this case, we've got 3 that they're almost the same. So it's easy to get them mixed up. So we'll start with some nice, tidy definitions just to sort of clear things up. So we'll start with SLIs. We'll start with SLIs, right? So what's an SLI? There's a great quote here on the screen, so I'll just read it out loud. A service level indicator is a quantitative measurement. That's an important aspect that expresses an aspect of the service is commonly a metric, right? That last part also is important. It's commonly a metric, but it doesn't have to be as well. We could talk about kind of why that is a little bit later on. The other word here, as I mentioned, is quantitative. Quantitative is a big word, but really what we're talking about there is you have to be able to measure it, right? And you have to be able to measure it with a reasonable degree of accuracy. And that's the other sort of important aspect of the word quantitative. It's not just enough to measure a thing, right? You have to be able to measure it to within a reasonable degree of accuracy. So 1, it can't just be a gut feeling, and 2, it has to be reliable. So what does that mean, right? Concretely, I'll give you some examples. When we talk about an SLI, right, we're saying that it is some sort of important element, some sort of important metric, some sort of indicator, right, about the health of your systems, about the posture of your organization, about the capacity of your business, of your organization to do whatever it is that you're supposed to do, right? A very simple example, or simplistic perhaps example, would be something like the number of hits you're getting on a web page, which, if you remember the World Wide Web from the 1990s, everybody was really, really proud of how many hits they got on their web page, right? And there we could go, okay, this is a thing that we can measure with a reasonable degree of accuracy, right? Because when someone visits our web page, which is all HTML1 and animated GIFs, on GeoCities, we would increase a counter. Probably it's a Perl script running in CGI bin somewhere. I'm showing my age. And that would increase a number. And we'll go, okay, that number is bigger now. And so we can measure that with a certain degree of accuracy, right? Every time someone loads the web page, this number gets bigger. But it's actually not quite enough, is it? Because we don't know necessarily when they visited. We don't know from there if it was the same person twice, if it was a different person. We don't know anything about where those people were from, right? So while that might be a good indicator in that we can measure it, it's not necessarily important to the goals of our organization, or perhaps just doesn't have enough information, right? So all of these things, when we talk about a service level indicator, these are all the sorts of things that I'm trying to communicate here, right? Is it has to be important. It has to be crucial, some way, which you're looking at this and going, if this number is where we want it to be, then we're winning, right? You have to be able to measure it with a reasonable degree of accuracy. And that context is important. When we talk about accuracy, we're talking about time, right? Think, for example, of Olympic swimmers, right? So we have these high-level athletes competing to see who can swim back and forth, across a pool faster than the other people, right? Their gold, silver, bronze times are fractions of a second. So if our granularity were 1 second, every single person in that pool would have a gold medal, right? Granularity here is important, and that is also an important aspect of accuracy. Conversely, if we are talking about hits on a web page, we probably don't need to measure it deeper than an integer. If we are measuring it as a floating point number, we're probably doing something wrong. Anyway, enough said about SLIs. Again, we're talking about a quantitative measurement that expresses an aspect of the service, and that's something that's important, right? These form the basis of SLOs. So what's an SLO? Here again, we have a lovely quote. A service level objective is a target value for a service. It's measured via an SLI. So it's a target value, right? It's an objective, hence the O in SLO. The idea here is to pick a reasonable value that should be maintained or strived for a given SLI. So we have an SLI, we've identified this really important thing, we know we can measure it with a reasonable degree of accuracy. Where do we want that number to be? And where do we want that number to be over time, right? Here's that aspect again of this cardinality, this dimensionality, right? Well, we can get into some examples, possibly in the demo, but the core idea here is that an SLO is a target, it's a goal, it's something to aim for, right? And spoiler alert, right? It's ultimately a way of measuring the success or failure of a service over time. And again, here these things all build on each other. So, SLOs are formed from SLIs. Well, SLOs are the basis for SLAs, right? So what's an SLA? And again, wonderful quote here. A service level agreement is a contract that defines the results and consequences, very important, of meeting or missing one or more SLOs. Now, there's actually a lot of information encoded into that statement, right? First off, let's talk terminology. Agreement, promise, contract, right? These are all related words that can be used to describe conceptually SLAs, right? The important thing here is that it's a statement that codifies what happens when an SLO target isn't attained, for whatever that means, if it's missed, right? In principle, that result could be anything, but it commonly takes the form of some sort of organizational or business decision, a financial repercussion, for example, right? You could imagine, or you could envision, for example, a pretty simple SLA would be, uptime. Talk about nines of uptime, right? 5 nines of uptime, 4 nines of uptime. What happens if your uptime agreement slips? Just go, oh, sorry, that's on us, and move on? Maybe, right? More commonly, there would be some sort of repercussion, maybe free credits on your cloud service, or an extra month on whatever thing it is you're buying, right? But hold on a second. We're talking about, business and financial outcomes here, right? We're moving beyond the realm of talking about hard drives filling up and, trying to empty our cache on the other side of the planet, which is an extremely hard problem. But we're moving away from technical issues now. And we're talking about business and financial outcomes. So as you might now be able to guess, there's more, than just monitoring tools and technical tools at play. And this is where you need to be able to bring in stakeholders, right? It's a team effort when it comes to identifying, scoping, defining, and ultimately implementing these things, SLIs, SLOs, and SLAs. And these numbers and targets are generally identified, set, and agreed upon internally, and then, of course, with your customers, because they're in service of the only stakeholder that matters, which is your customer, right? Your user, your consumer, whatever that means for your organization. And when you focus on user experience, as opposed to a hard drive's filling up, or I can't empty this cache, then you're on the right track, right? It's about user experience. Now, for those of you that joined us for the second webinar just a few weeks ago, and I sincerely hope you did, you'll remember me talking about this in the context of tracing and APM. If you don't remember me talking about that because you didn't see it, go back and watch the video. But the nugget here that I want you to take away is that just because something ultimately works, it doesn't mean it was successful, right? So again, thinking back to the previous webinar, remember the 4 golden signals, right? Those metrics are super, super important. It brings us on to sort of data-driven, decision making. There's no substitute for humans doing what they do best. And I don't mean constant guesswork and firefighting, although we are good at that. Good data helps you make good decisions by lowering cognitive load. That's critical, right? You want to empower teams to be independent, and that's going to unlock creativity and potential. But lowering cognitive load is a big part of that. Getting the computer to do what the computer does so that humans can concentrate on what humans do. That's extremely important. And another area where this principle occurs is, interestingly enough, as if we planned it, security. Right? People in organizations tend to fall into one of two camps when it comes to security hygiene. Either they have no real understanding of it and are completely paralyzed by it, or they understand it extremely well and are thus completely paralyzed by it. Both of these extremes are problematic. So I'd like to introduce a way that Datadog can help you deal with what is frankly sort of a complicated topic. That's security posture management. We offer an entire security platform integrated with and into our product and service offering. It's newish, right? And we're really, really excited about it, and we're developing it, constantly and improving it constantly. And frankly, there's a lot we could talk about here. It's an extremely large, well-integrated product, but I want to concentrate on one piece with regards to this idea of letting the computer do what it does best so that humans can really do what they do best, which is security posture, management. We'll explore this a little more in the demo, but the idea here is that Datadog sort of acts like your own personal OPSEC team. Well, maybe not quite that far, but the proposition of cloud security posture management, or CSPM, because we're technical people and we love acronyms, is a set of tools and practices that make it easier to figure out where you're at from a security perspective. Now, the word posture here is important. It refers to the positioning of a body in time and space, if you were to look up in a dictionary, right? And it also refers to that body's bearing. It's about direction, it's about velocity, right? And in the context of security, posture is a pretty common term to more or less describe these things at an organizational level. What is your organization's bearing? What's its positioning? And moreover, is that posture actually safe enough? And further still, what can you do to improve your posture, right? It's good to know where you're at, but if where you're at's not good, how do you get better, right? Knowing, as they say, is half the battle, but actually improving the situation is going to be clearly the other half, right? So I get brass tacks, there's a lot to go into, and we'll see some of it in the demo, but I do want to bring up one more item, and that's security signals. So we'll take a little brief detour into this before I hand over the reins to Ara. So once again, definitions, right? What's a signal? What's a signal? Well, a signal is feedback, right? It's a gesture, an action, a sound, an electrical impulse, right? Something that's used to convey information. In the context of Datadog, in the context of this product, security posture management, when we say security signals, we're talking about feedback that is generated by our security monitoring platform based on detection rules. Once again, terminology, right? So detection rules. They define conditional logic that is applied to all of your logs that are coming in and events and things like this. And when at least one case defined in a detection rule is matched over a given period of time, again, this idea of dimensionality, Datadog generates a security signal. Right? So it looks at the incoming information. It says, that looks weird. I want to tell a human about it. In other words, it's a rules engine, right? Writ large for the cloud era. Logs go in, rules are applied. When conditions are met, a signal gets generated. And a really compelling element of the system is that we provide out of the box, or OOTB, detection rules to flag attacker techniques, potential misconfigurations, all sorts of stuff, so that you can immediately take steps to improve your security posture. And this relates to a lot of what Studi was talking about, right? It was talking about security posture. It was talking about how do you organize your organization, and how is that organization represented within your infrastructure, within your AWS structure, right? It's not necessarily difficult, but it can be. And the bigger your organization is, the more stuff you have, the more people you have, frankly, the more room to make those mistakes happen. And this is an out-of-the-box way to help you find and mitigate some of those potential areas for confusion and misconfiguration. Last thing I want to mention, again, before I hand it over, is that we continuously develop new detection rules. We're constantly working with security leaders as well as security community at large to import new detection rules. And all of these are automatically imported into your account. You don't need to do anything, right? This is just an ongoing process. And of course, you can make your own as well, right? Which is also really important. So we're not being prescriptive here. You can create your own rules. I think that's it for me. So I will hand it over to Ara.
Fantastic. Thanks, Dan. So let me share my screen so we can do the demo. So I'm going to start the demo by doing a little bit of recap, because basically our demo was had 3 phases for the 3 episodes. And so I'm going to do a recap a little bit of what we did on the first 2. So basically our idea of the demo is we have been accompanying this potential company that is moving to the cloud. And they decided to move first this application. They have a web app that is an e-commerce app, which is classic 3-tier web application with a presentation layer, most of the logic in a monolith with a couple of services on top, and all backed up by a Postgres database. So what we did on the first, and by the way, this is the application. It's actually a running application. So the 2 services, small services that it has, apart from all of this monolith, is just this part which serves discounts, and this part here which serves ads. So one of the techniques that we saw on the first episode was this concept of shift and reshape, which is a little bit similar to shift and left. Basically, the idea is to move all the compute just as it is, as you had it before, as a first step, to VMs, which basically is the equivalent to your server in your rack. It's basically an EC2 instance. So we decided to move all the logic of the storefront here to an EC2, and then the ads and the discounts services, we move it to other EC2 instances as well. So just plain VMs. The only thing that we started leveraging a little bit different from what we had before is this bit here. So we decided to use RDS, which is a managed service by AWS. So we had things like automatic backups and things like that. And it was fairly easy to do. So we did that on the first episode, and we saw things like how the integration that Datadog has with AWS give us things like this default dashboard. We saw a lot more on that episode, but for example, the number of EC2 instances that we have, the status, the CPU usage, etc., etc. So we focus on that first part on the first episode. What did we do on the second one? On the second one, we decided to identify services that may be better to use different compute on AWS. And we decided to move the ad service to an orchestrator, a container orchestrator called ECS, using Fargate. And ECS Fargate is basically a container orchestrator that also lets AWS manage the capacity planning for you as well. So you don't have to think about what is actually the compute that runs your containers. We also moved the discount service to Lambda, and Lambda is a function as a service service in AWS, which is very common to use for small services, event-driven application, etc., because it only charges you every time that you call it. Once we started splitting the application this way, we saw that it was important to use distributed tracing, and we saw that we had instrumented our application for tracing, and thanks to that, we can see things like all the different services running in our application live with the requests that we're having, the latency that we're having, etc., etc. Thanks to distributed tracing as well, we were able to identify that version 1.2 of our ad service had a very high latency. So we used distributed tracing to understand where that latency was coming from, pinpoint to the service that was causing the latency, and also we used profiling to know exactly what part of our code was causing that latency. So that's where we left. So what we're going to be doing today is to, again, move to the business side of things. So this was, let's imagine this was a real incident. So we had a very high latency that was causing our customers to have a bad experience. So thanks to identify that, we were able to say, okay, let's fix quickly the issue. We are running, remember, this ad service as a container. So we built a new container image, we push it to ECS, and one of the great things of using a container orchestrator like ECS is that you have what we call a rolling update. So we don't have to stop and remove that service to be running. So basically what is going to happen is AWS is going to create the new containers for the new version, and it's going to start shifting traffic from the previous version to the next version. And we see here this. So we had this high latency. This is the ad service page that you get in Datadog when you're instrumenting your application for tracing. And you can see that the latency was very, very high and suddenly dropped. This was when we released the new version. We can see here the difference between version 1.1, which was the version that had the issue, and version 1.2 that fixed. We can drill down actually and see exactly how that was happening. And again, super important, thanks that we are using a container orchestrator like ECS, we having a rolling update. So we never lose service with that particular service. You can see here, this is version 1.2. Sorry, this is version 1.2, this is version 1.1. And you can see at some point in time, both versions are receiving traffic. And it's super important to be able to have this type of visibility as soon as you start decoupling all your services and having many, many of them. So we can see that at which point this happened. So the new version here, and again, super nice to have an orchestrator, because let's imagine that this version here wouldn't start or our container would crash, and we wouldn't know until we have in production. The good thing is that ECS would have stopped that deployment from happening. So if we start a rolling update and that rolling update start crashing, they would shift traffic again back to the previous version, which is really nice because it avoids downtime for users. Again, what we wanted to fix here, it was a latency issue. And we can see here that the previous version dropped here because basically we removed that as soon as the new one that started a little bit earlier, again, rolling update, started to gaining traffic. So very important as soon as you start doing microservices to have this type of visibility, doing updates, knowing exactly what is happening. So our hypothetical company was very happy that we were able to identify this issue and fix it, but they wanted something else. They wanted to avoid, they ran blameless postmortem on why this happened, and they wanted to make sure that this didn't happen again. So we decided to create an alert, a monitor in Datadog. Basically, we want to say, okay, as soon as the latency of that ad service, the P95 latency of that service goes beyond 200 milliseconds, which already it's a lot, suddenly we want to make sure that we don't alert on things that can be caused by something else. For the last 5 minutes, to avoid alerting if you have a spike that then goes down, to alert us. So as soon as it happens again, we are very quick in fixing it. And we can see here that this monitor has been running for a while since we deployed that version, and all is good. So right now,
this actually is a great example. We were talking about, SLIs, right? And to focus on experience, to focus on, are we actually delivering what we promised to deliver, and are we delivering it in a way that our consumer expects, right? And P95 latency is a good sort of indicator there, right? Because you're not saying, a hard drive somewhere is broken, or you're not saying there's a switch somewhere that's bugging out. You're saying that user experience isn't where we need it to be. And that's actually what you want to be alerting on. That's something that's actually worth waking somebody up over, right? And I just want to sort of point that out.
Perfect. Yes, and actually we are going to see now another thing, which is SLOs in particular. So we've seen that in this company, the ads service is very important because it drives, and we go back to the business value, it drives a lot of business. So a big chunk of the revenue comes from ads, and that can happen in many companies. It's good or bad, internet is completely ads driven. So it drives a lot of business value. What happens is that sometimes when you're trying to push a lot of features on and on again, you can make mistakes. And that's why monitoring, observability, all these things are super important, because these things happen. So this is what happened with the ads team. The ads team decided to push new features very quickly. This is actually version 1.3 of our ad service. And suddenly what happens is that container image wasn't working correctly. It wasn't crashing, because if it was crashing, it would have been the container orchestrator who would have dropped that update, but it wasn't crashing. It wasn't just working correctly. So it was good that we had, again, observability and tracing here, because we saw all the errors that were coming in from that version. And again, if we look by version, so 1.2 was the one that we fixed the latency issue from, 1.3 is the new one that had the issue. You can see the number of errors. So the other one wasn't hitting any errors. Suddenly version 1.3 was having a lot of errors. Good thing is that we had monitoring on it. We had this through the tracing. We were able to revert back to version 1.2 very quickly. We only had about a couple of minutes, well, maybe more, maybe 10 minutes, 5-10 minutes of downtime. But obviously that, because it drives a lot of revenue, that went high up on the management ladder, and it was very important to drive that postmortem correctly. So that postmortem was driven, and one of the reasons that the ads team was saying is that, okay, because I always have to push more and more features, which is the thing that we want to do. We want to, as developers, as product managers, we want to move the business forward, adding more features, but because we are adding constantly features, we don't know when we should be focusing on reliability instead. It's impossible for us to know when it's starting to become too risky to push more features. And that's where SLIs and SLOs come into play, because it's a great way to balance those two. Why? So in this case, we have created an SLO that says, okay, 99% of my requests to the ad service has to be successful. And the way I do that is basically I do a query that says, okay, give me all successful, all 200 requests to the ad service divided by the full amount. And that has to be over 99% of them for the past 30 days. So in the past 30 days, if I had 100 requests on that 30 days, 99 of them has to be successful. If not, we are going to be starting to reduce what we call the error budget. And the error budget is critical because it gives you a hint on when you need to start fixing things. Maybe Dan can give us a little bit of overview of why an error budget is also super useful.
Yeah, sure. So the idea behind a budget is pretty straightforward. There's a fairly good chance that you out there watching it, internet land, have made a budget of some type in your lives, and this is not necessarily that different, right? The idea is that you've got sort of a certain amount of credit, a certain amount of goodwill, a certain amount of something to spend, right? And you have to, spend it or dispense with it in responsible ways. So what does that mean in the context of SLOs and SLIs and SLAs and these wonderful acronyms? So here, what we're basically saying is, if you are hitting those targets, right? If you have these, you've defined these numbers, you said these are important numbers for us, and we want these numbers to be at or about, a given value. And if over time, over defined time, you're achieving that goal, then you've got a big old budget to spend. What does that mean? It means you can do risky things, right? For definitions of risk, okay? That could mean, deploying new features. That could mean, rolling out new infrastructure. That could be, making different changes. That, whatever that means, right? But taking the system that you know to be stable and functioning, or at least meeting the requirements for stability and functionality that you've defined, and making a change. Hopefully that change doesn't negatively affect you. That's the idea, but sometimes it will, right? And when it does, when your targets begin to slip, that's when you start to lose out on that budget, right? You're spending that credit, and as your budget decreases, you need to take remediation steps, right? So you go, we don't have enough budget to spend on a given risky behavior. We need to stop and we need to fix problems. That's the idea.
Great explanation. So that gives us a way to discuss with product management as developers, and product management to discuss with the rest of the organization when we need to focus on reliability. In this case, we have an error budget left of 86% because we had some errors over here that decreases that budget. When it goes down, we can say, okay, we cannot push those features in because we need to focus on fixing issues with our code to make sure that those problems don't happen. Good. So to finish, we wanted to give a little bit of overview of posture management. So study has explained very well all the things that you need to take into account when moving to the cloud, particularly for security. So the ways you have to define your configuration, your roles, IAMs, all the different options that you have for your cloud. And as you move to more and more services, you start using S3, you start using load balancers, you have to use different type of EC2 instances, etc. It may be difficult to track everything. It's normal to make mistakes, and those mistakes, you can audit them manually or maybe with external audits. But it's good to have some best practice, some good posture that we call it, that can tell you the things that maybe you have to think about. And let's just put an example here in our accounts. For example, this rule, S3 buckets. S3 bucket is a storage for AWS, employs the default encryption address. That's the thing that needs to happen. And it's going to give you all the resources that you have that are failing that rule. You may or may not want to remediate those, depending on what you're storing on that S3 bucket, but it gives you an idea of things that you need to look at. And not only it gives you the resource in your AWS account that is failing that best practice, it gives you the remediation. So it gives you some tips on how you can go quickly to your AWS account and fix that problem. So that way, instead of having to go through every single one of those manually and see if they're configured correctly, at least you have a baseline. It's not going to make it everything perfect, but it's going to give you a baseline so you can focus on the difficult problems of the security, not just problems of configuration. So that's it for the demo. I'm going to stop sharing my screen now. And I think we have some minutes for questions.
We sure do. We've got time for just a few, so let's see what we've got here. All right. Regarding SLOs, we've seen a 30-day SLO in the demo. Do SLOs always have to be 30 days?
So obviously, you are able to, you can, if you're not using Datadog, for example, you can have your SLO for whatever many of days. If you're using Datadog to make those calculations, which are difficult calculations to make by hand, you have 3 options. You have 7, 30, and 90 days, which is usually what people ask for, either a week, a month, or a quarter.
Okay. Is there a way in Datadog to avoid monitors alerting at certain times of the day? I would assume you wouldn't want them to be going off in the middle of the night or other times like that. So how do you kind of are they customizable, I guess is the question.
The answer is yes.
Awesome. Short
Yes.
and sweet. I love it.
But it's important that some alerts go in the middle of the night.
Yeah, and there's going to be stuff. Yeah, there's absolutely going to be stuff where, this is a Sev 1, wake up the president, right? Apocalypse scenario, right? Where you don't want to ever turn that off. But those types of alerts should be so few and far between, in your infrastructure as to be almost unrecognizable when they occur, right? In general, you're going to want to put together a program where things escalate, in composite monitors, and then, combine that with a path within your organization where maybe it'll start with a gentle nudge on Slack, and then maybe it'll, send somebody a ping on their phone, and then so on and so forth before, someone else ultimately gets woken up. Yeah.
Gotcha. All right. This one's for Stuti. What is the relationship between a microservices architecture and event-driven architectures?
That's a great question. Actually, it's kind of a subset. So event-driven architecture is a subset of microservices architecture. So in microservices architecture, you are really decoupling different components within an architecture and reducing the dependency over others, thereby improving the scalability and durability and agility as well. With event-driven architectures, services in an architecture communicate between each other with event messages. So basically, event-driven architectures are a subset of microservices architecture.
Okay. All right, so I think we can squeeze this one in here because this is a really great question. How do you create an error budget?
That's a great question. So the thing is that, and again, this is calculations basically. If you say you have to have 99% of your requests to be at 200, and you have 100 requests, that means that one of them can be non-200, can be an error. If you have 200, that means that you have a budget of 2. Obviously, the more requests that you have, the more requests that can be an error you can have. Good thing is that that error budget is automatically calculated by Datadog at all times. So as soon as you get more requests, that is updating that error budget automatically for the time frame that you've put. So you just create your SLO and it's going to calculate the equivalent error budget for it or associated error budget.
Or put another way, you don't actually create the error budget, right? You define your objectives, right? Which is something that a human is good at, and the computer calculates the budget for you because that's what the computer is good at.
Okay. All right, folks. So we are right up against our time, but I wanted to squeeze that one in there. Thank you all so much for this amazing presentation. And thank you to the audience for spending your time with us today. Just a reminder, this has been recorded You'll get an email with instructions for how to access it on demand, or you can always visit us at devops.com/webinars, where this and the other episodes in the series will be available for you. We went ahead and drew our Amazon gift card winners just a few minutes ago. So congratulations to Mallory C., David C., Javier G., and Bipol K. Congratulations to all our winners. Thank you again to our speakers and to our audience for joining us. And we hope to see you again at another DevOps.com webinar very soon. I'm Sharon Florentine, signing off.